In this video, I'm going to be going through some examples of sequence and series. So specifically, I'm going to be talking about the arithmetic series as well as the geometric series. Okay, so here I've given you some formulas. Geometric. Okay, so here I've given you some formulas that you need to remember to know how to do a problem with the arithmetic and geometric series. Okay, so the term n is, for arithmetic series at least, defined to be a plus n minus 1d. Okay, so n is the number that we're after, d is the difference, and a is always the first term. Okay, so for example, if I go 3, 5, 7, 9, and so on, a is equal to 3, right? So this guy over here is a, and d is going to be 2, the difference. Okay, now the sum, so I'm not going to be deriving any of these equations, right? So I'm more focusing on the problems over here. The equation for the sum is going to be n on 2, so the number of terms that we have divided by 2, and in brackets, so times a plus n minus 1d. Now in most books you will say 2a plus n minus d, and that's perfectly fine as well, right? So I can just combine this to be 2a. But the reason I'm doing this method is so that you can see that this thing over here, the last a plus n minus 1d is actually your last term. Okay, so that's where you actually end up getting the 2a. Alright, the next thing, for a geometric series, in the same way that you're adding the differences, right? For a geometric series, you're going to be multiplying the ratios. So R stands for the ratios. So we're going to multiply n minus 1. So just notice over here how it's n minus 1 over here, and also n minus 1 over here, right? So we're multiplying n minus 1 ratios to the first term. And the sum is equal to a times 1 minus r to the n. Now this time n is the number of terms. Okay, so don't make a common mistake that I see is that the n minus 1 for the actual term and this thing for the sum get mixed up a lot. Okay, so remember for sum we are just concerned about the number of term, not n minus 1. Okay, so we have a times this, or 1 minus r to the n divided by 1 minus r, so the ratio. If you really want to, you can write it as this as well, so r to the n minus 1 on r minus 1. The reason why, I'll leave that as to you as a proof, but the idea is taking out a negative. Okay, anyway, that's something for you to look at. Okay, now I'm going to be, for this tutorial, I'm going to be focusing on 5 problems. All right, so for the first one, I need to get how many terms I need for this series. So notice that it's a geometric series. Sorry, my bad, arithmetic series. How many terms do I need to get 352? Okay, the second one is asking me to do, can you find out what a and d are? So what is my nth term, right? So what is the nth term if I was given the sum of a series, right? I don't know if so this is a arithmetic series. What is the nth term? The third question is asking me to do the sum of this geometric series. So now we're talking about geometric series over here. Okay, and same with over here. It's another geometric series. Now what's really going to be interesting is the fifth one. Okay, so you'll see whether it's the question that I'm asking over here is it a geometric series, right? Or is it an arithmetic series? So that's really what's tricky over here. For the fourth one, what we're going to deal with is this thing called infinite series. Okay, all right, let's get started. So for question 1, it's asking me how many terms do I need over there. Any question that you have, first write down your data. Okay, so in this case I have a is equal to 7. So let's go back over here. So oops, a is equal to 7. The difference is 2, right? The difference is 2. I need to figure out how many is equal to 352. 7d is equal to 2. Sum of n is equal to 352. So write down your data. We need to figure out what is n. Okay, so I'm going to write down the equation of the sum so that you can see it clearly. So S of n is equal to n on 2, 2a plus n minus 1d Okay, now what I'm going to do is I'm going to sub all these values and expand this bracket out. Okay, so 352 is equal to, it'll be in this case an, so a is 7, right? 7n, and then now remember d is equal to 2, it'll cancel out with this 2 over here, and so I will basically have n times that, so it will be plus n squared minus n. Okay, so on this side I will have n squared plus 6n, and I'm actually going to take the 352 to the other side, so minus 352 is equal to 0. Okay, so now it's just a matter of solving a quadratic. So using the usual quadratic formula, I can solve for this, and then I will end up the whole minus b plus or minus square root of b squared, right? So I'm not going to actually say this out, so I'll let you look that up for yourself. But it's going to be minus 6 plus or minus square root. Okay, so I don't have what the square root of is, but it's going to be plus 38, plus or minus 38, all on 2. Okay, so whatever the square root was end up being 38. Now, remember that n is the number of terms that we need. So we're not really going to concern ourselves with the minus case. So we can forget about that altogether. So all we have is 38 minus 6, which is 32 on 2, 16. So we need 16 terms. Okay, question 2. So question 2 is asking me to find what is the Nth term for this guy. So I'm going to be needing this thing over here. Okay, so I have Sn is 3n squared minus 11n. Let me expand this thing out. When I expand that out, in general, I have Sn is equal to n, right, plus, okay, what do I have after that? So I will have these two multiplied, so it will be nd on 2 times this bracket over here, right? So I'm just going to do that in one go, so it will be n squared d on 2 minus nd on 2. Okay, and then I'm going to collect terms, so with the n squared and the n, right? So I have n squared d on 2, and then if I take minus n outside, I will have d on 2 plus, oh, sorry, not plus, that's actually supposed to be a n, right? So that's going to be minus a. Okay, so so in that case, what I can say is that d on 2 has to be equal to 3, meaning that d is equal to 6. Okay, so all I'm doing is equating this term to this term over here. And d on 2 minus a has to be equal to 11. Okay, so going by this thing over here, a has to be equal to minus 8. Okay, I know I'm rushing through this, but I'm hoping that you can stop and look at the video, right? Let me know in the comments if I am rushing too much. Question 3. Alright, so this is just really a application of the geometric series sum. So I have 3 plus 3 plus 3 to the 4 on 3, 3 to the 5 on 3, and so on. Okay, now this 3 over here, just 3, I can write it as 3 to the power of 1, or rather 3 to the power of 3 on 3, right? So now you should be able to see that the ratio is simply a matter of 3 times 1 to the 3. Now we can just use the sum formula. So I have a is equal to 3, r is equal to 3, 1, 3. We have n equals to 10. That's what they're asking you for in the question, right? So it's now really just a matter of applying the formula. So Sn is equal to a times 1 minus r to the n, all on 1 minus r, right? Now I'll just get you to fill in everything from here, okay? And that's all there is to for that question. and there's not you can't really simplify this question, okay? So because we're dealing with indices, you can't simplify the question. You just leave it as it is. The only thing I can say to be cautious about is this r to the n term, which will end up being 3 times 10 on 3, right? Because it will be 3 to the 1 on 3 to the power of 10. Okay. Okay, question 4, infinite sums. So I have 16 minus 8 plus 4 minus 2 and so on. Okay, so if you can see, we're halving it, and also the sign is changing. In that case, the sign matters as well, so you need to know that r is equal to minus a half. Okay, a is equal to 16 given. Now n is going to be infinity. Okay, so I'm going to sum infinite number of sums. Now it turns out, coming back to the original geometric series equation, right, so all the way up here. Now let's look at this equation over here. It has a times 1 minus r to the n. It turns out that if r is between 1 and minus 1, this r to the n term over here will disappear. In fact, it will go to a 0. Okay, so if you want to try it, so suppose you have 0.1. Okay, now if I take 0.1 squared, it's equal to 0.01. 0.1 to the cubed is equal to 0.001, and so on. So it's, if you can see, my point is that it's getting smaller and smaller, right? So if I take to the power of infinity, this will be, well, it will be 0, right? So the limit rather will be 0. Now it turns out this works for any number that is between minus 1 and 1, not including 1, of course, not including minus 1 or 1. But for any number that's even slightly smaller, you can plug it in your calculator and play around, right? So just keep taking the squares of the answer. You'll find that the number gets smaller and smaller and smaller. Okay, so that's why this term over here disappears, and all we're left is a times 1 on 1 minus r. So writing down the equation for infinite sum, it's simply going to be a, so I said a times 1, which is this a, all on 1 minus r. So in this particular case, I will have 16 on 1 minus a half, okay, so which will give me a plus half, right? So because it's a minus already over here. So the final answer for this one, from my working out, was 32 on 3. Okay, so let's get to the more interesting, the most interesting question, I guess. So this one, so ln is natural log, okay, so log base e. But what I want to do is sum up the 10 terms. Okay, let's write this down. So I have ln 3 plus ln 6 plus ln 12 and so on. Now if you thought this was a geometric series, it's not. Okay, so I want to sum up 10 terms of this, because if you expand this out, right, this is equal to ln of 3 plus ln, so 6 over here can be represented ln of 3 times ln of 2. ln of 12 can be represented as ln of 3 plus ln of 4, sure, but I'm going to write it as 2 squared, okay? And then the next term, ln of 24, can be written as ln of 3, so it's 3 times 8, so ln of 2 cubed. Okay, so basically what we're going to end up with is 10 of these ln 3 terms. Okay, and then the rest of this, these terms over here, the ln2 squared, ln2 cubed, can be written as, so let me read it. So ln2 plus, the powers come up in front, 2 ln2 plus 3 ln2 and so on. Okay, so just to make it absolutely clear, this is what's going to happen. So I'm going to factorize ln2 out of these things. So I will end up with ln2 in brackets 1 plus 2 plus 3 all the way up to 10. Okay, so now this part is a arithmetic series. So it will end up being ln 2 times, so there's 10 terms, so applying the formula n onto a plus l, right, I will end up getting 10 on 2, which is 5, 1 plus 10. Okay, so the final simplification of this problem is going to be 10 ln 3 plus, so that's 5 times 11, so 55 ln 2. And there you go. If you have any questions regarding what I did, or maybe if I was going too fast, let me know. But hopefully the video will let you pause it and let you work it out for yourself. If not, ask me by all means. Please subscribe, and thanks for watching.